Hello and welcome to Engineering with Rosie Live. If you can just give me a little wave or something in the comments to help me to make sure that everything's working okay, and tell me where you're calling in from. I already had a couple of comments from Americans, and sorry that this time doesn't suit you guys so well, but yeah, unfortunately that's the nature of the spherical globe, that we can't get daylight for everybody at the same time. So in this live stream, we're going to be talking about the options that are available to decarbonise building heating. And we have a special expert guest here, Glen Ryan. He's the co-founder of a couple of clean tech companies, actually, the current one being Sunovate, which is solar thermal, so very relevant for today. So I'll get Glen to introduce himself in a second and tell you a bit about his background. But in the meantime, let me know in the comments, what do you think are the biggest challenges for decarbonising building heating, and what are your favourite technologies to use? So tell me in the comments. So I just need to start by thanking the sponsor of these live streams. That's WeatherGuard Lightning Tech. WeatherGuard makes strike tape, which is a retrofittable lightning protection system for things that go fast, like wind turbine blades and aeroplanes. These live streams wouldn't happen without them, so definitely a big thank you for their support. And also the whole Engineering with Rosie channel is supported by the amazing Patreon community. We're up to about 100 in the team now, and we always love to welcome more. So Glen, can you please tell us a bit about your background and what you're working on now with Sunovate, and like what led you to start that company?
Yeah, certainly, Rosie, and thanks for the opportunity to jump onto your show. I'm, I guess, a serial clean tech innovator. So I've been doing clean tech innovations for the last 20 years. Started off with a little bit of wind, then I developed Bombora Wave Power now, which is a technology based in the UK, so a large-scale wave energy device. And my latest, I guess, clean tech innovation is Sunovate. So Sunovate's a PVT solar thermal solution. So we generate, during the day, we generate renewable heat and electricity, and at nighttime renewable cooling. So we keep the panels cooler, they produce more electricity, and we harness that heat, and we can use it for space heating, water heating, pool heating, and industrial processes. So that's a very simple spiel of what we do, Rosie.
Okay, and so why did you start that? Did you have the technology idea and then look for an application, or did you notice that there was, some inefficiency that needed to be solved?
Well, it was, I guess, a personal experience after, I guess, installing our 3 kilowatt at the time PV system about 10 years ago. And we were sort of excitedly waiting for summer to come around to see how much the system would produce. And we noted that in the middle of the day when it was really hot, it was only producing 1.9 kilowatts, so not the 3 that we were envisaging. And I guess then we got to learn a little bit more about the thermal degradation of PV cells in our hot Australian heat. So those cell temperatures were getting up to 90 plus degrees Celsius, and they're only rated at 25 degrees in the laboratories. So quite a significant thermal derate. It's roughly around 5%, which is done for every 10 degrees above those test conditions. So that's where our technology was born. And yeah, we've managed to cool the panels, bring them back down to normal temperatures, and harness a hell of a lot of heat off them.
Okay. Well, we'll talk more about that when we get onto solar thermal. Yeah, so basically in today's live stream, we're going to talk about 2 things. First, just the whole idea of the challenge of decarbonising heat and how big the problem is and why it's important to solve and why it's hard. And then we'll talk about the technology options, and there's probably too many to cover in a lot of depth, but I especially want to talk about heat pumps, solar thermal, and also seasonal thermal storage, which is something that I only learned about recently, actually from you, Glen. You told me that even existed. So yeah, it's funny actually. And both of us are probably sitting here in t-shirts. I don't know what sort of temperature over there in Perth, Glen.
It's a cool 33 degrees today. So
Yeah.
we've had a run of 6 days over 40 degrees. So it's pleasant conditions now.
Yeah, right. We didn't have as high temperatures today, but yeah, it's definitely been hot. But of course, most viewers are in the Northern Hemisphere, and you guys over there are suffering mostly through a cold winter. I'll just see who we've got joining us. Got Peter Ross. Hi, Peter, from Orange, New South Wales. Probably hot there too, hotter even than where we are. We've got another Peter F, who says hi from early morning in the UK, and I think it is early. It's like 7 a.m. there. So thank you for getting up early. Who else have we got? David Montgomery calling from California at 11. So yeah, you could say we're 6 hours behind, but a day in front. Yeah, and your sister went to UC Davis Law School. Yeah, I went to UC Davis for 1 year studying aerospace, so that is a small world. Okay, yeah, so let me just get back to what I wanted to talk about. Oh yeah, I wanted to talk about my inspiration for wanting to do the video on heating, because as an Australian, it's not something that I ever really thought about that much. Heating is not really a hard challenge here. But when I lived in Denmark for 5 years and learned about district heating, we had district heating where I was in Kolding. It comes from a combined heat and power plant, and they're mostly burning biomass, I think, in the wintertime anyway. And it's very cheap. It was very toasty warm. The buildings were built well, or at least they're built well for, holding heat in. They're also held moisture in. I was constantly suffering with mold, which I didn't enjoy. Yeah, but so I was perfectly toasty through Danish winter, and Danish winter is miserable compared to an Australian winter. But when I came back here to Canberra, where the temperatures do go below zero overnight, but way above zero every day, and I was just freezing my way through the last winter, because we don't do double glazing as a rule. There's drafts everywhere. There's always air coming in from outside, not that much insulation. My apartment has both natural gas heating and also a heat pump, which is kind of a weird combination. So anyway, it made me realize how different the heating solutions are for different places in the world. Yeah, so basically that's what I wanted to talk about today. And I will just share, I did a poll on YouTube and the community page. Let me share that. Asking what's a preferred option to decarbonise home heating where you live. I could only put 5 options, so obviously I couldn't include everything, and they also kind of combine together. But basically people like energy efficiency and heat pumps, which is what I like too for where I live. People really not keen on biomass, which is interesting, because I think the vast majority of heating in the world is still done with biomass. At least that makes up the bulk of the renewables. A few people interested in hydrogen, and then district heating, obviously it combines with some other form of generating heat. So yeah, that was interesting. And then of course there were a few comments that I had missed out, solar thermal. So we will be talking about that as well. Okay. Yeah, so I just want to start by talking about how big is the challenge to decarbonise heating, and I will share some information from this report from ARENA and IEA about renewable energy policies, heating and cooling. So just wanted to give an overview that 50% of energy used globally today is for heat production, and it's responsible for 40% of energy-related greenhouse gas emissions. And then I've got some figures as well from the same report. So this is total energy consumption in the world, 49% of it on heat. And then if you look at the breakdown, this is the energy for heating and cooling. Then we've still got 72.5% on fossil fuels, and then 11.9% traditional biomass, which is just like burning stuff, burning wood or dung or anything where you just set fire to it and use the heat. 5.2% on non-renewable electricity. So I guess that part of it is going to go away as we decarbonise the electricity grid. And then 10.4% on modern renewable energy, 6.9% on sustainable bioenergy, renewable electricity, solar thermal, renewable district heat, and geothermal. So Glen, over to you. Can you tell us a bit about the context for the problem? Why are we still at 72.5% fossil fuels? It's a big proportion, and a big proportion of a large proportion of our emissions.
It's massive, and I guess it's not sexy. That's probably it's the trouble with renewable heaters. It doesn't have this that sort of appeal in terms of the media, but it's certainly a massive problem when you're confronted with those charts there. So, and if we look to, like as you said, to the right there, we're just starting to make an impact into that arena. Part of it is obviously to do with just our traditional energy systems. A lot of focus historically has been put on renewable electricity, so wind and solar. And part of the benefit you get there is 1 watt of solar, 1 watt of energy generated on your roof is 1 watt of electricity you can use in your house, versus it coming from potentially like a combined heat and power station, which is you still got to put 100% units in to fuel the system, but you might only be getting, at best 60% with a combined heat and power, and as low as 20% with some gas turbines in terms of electricity. So, the amplifying effect of decarbonising the electricity system has been, I guess, more attractive because it gets closer to the customer. But we just see also the biggest issue is there's just been a vacuum of policy setting in this space, and we're just starting to see some serious attempts being put in through Europe in terms of renewable heat targets. And that I think has been probably one of the predominant issues in this sector not being addressed as quickly as we expected it to be.
Okay, and so what about some of the challenges? I mean, I've been watching the efforts to decarbonize heat for a while, and some of the proposed technologies and the challenges that people raise. It's like about seasonality. Obviously, if you've got if you want to use renewable electricity for your heating, then it's a problem in places like Northern Europe where you don't get a lot of solar power in the times when you want the heat.
Yep.
And then also just like the big volume or the peak demand that you need from heating is a lot more than what the electricity grid has been designed for. Are both of those valid criticisms or problems?
Yeah, there certainly are. Gas has been super cheap, and I guess it's typically it's 80 to 90% effective put through a gas boiler, so it's cheap, and it's I guess also large institutional investment behind those in terms of pipelines and large companies that are backing that. So they're fairly well entrenched into our energy systems and energy markets. The point you raise about seasonality is extremely valid. One of the challenges that solar has historically faced is that we have these solar droughts during the middle of winter. So how do we sort of cover those 5 to 10 days that might have poor solar if we rely too much on that? And I guess we see Denmark and Netherlands leading in that respect in terms of seasonal storage solutions. So Denmark in terms of those large pit storages that we spoke of, and the Netherlands are looking at aquifer storages. So ground storing the energy in the ground over summer, which you can then withdraw out over winter as a big thermal buffer. So that starts to address that. Obviously, that requires a lot of capital, and I guess the incentives to drive into those markets. But that's certainly a key enabler for higher penetration solar. And I guess historically people said, oh well, the northern Arctic areas aren't really good for solar, but I'm amazed by the amount of solar PV that's going in. So it's quite phenomenal that that market's really taking off. And I think the last point you raised about seasonal storage, there was just the gas as well, the peak demand. So one of the issues that we face is that chart that you put up just earlier, where half the final energy demand is heat, and a quarter is roughly electricity, and another quarter is mobility. Yeah, that one there. So what we're actually asking is that bit that's got 22% of our final energy demand, we're kind of asking it to sort of load up more and more of those other energy carriers into that segment. So that's going to require massive investment. So the trouble is everyone wants heat at the same time or cooling at the same time. So how do we actually harmonize these systems? And thermal storage, I believe, is a big way of resolving both some diurnal and short-term swings, but also the seasonal swings as well. So we can release those networks or those peak demands through these new innovative technologies.
Yeah, okay. I mean, you've raised a lot of really interesting things. I think we'll get onto the specific technologies now, and then we can talk about the features that are relevant to that then. So can we, first of all, can you tell us about heat pumps? So obviously there's air source heat pumps, ground source heat pumps, and then there was another one that you wanted me to mention, the
PVT assisted heat pumps
yeah,
as well.
that's it.
So
Yeah.
yeah, air source, we're a big fan of air source heat pumps, but we do understand they do come with some limitations, and part of that was that grid augmentation piece. So in principle, for the listeners, the heat pump, how it works is essentially it's a thermal system. It uses electricity to drive a compressor, and in terms of heating the house, what it does is it basically pressurizes the air. It then runs that through the evaporator, which you can see inside the coils inside the house, which blows the hot air. And then it comes back out after cooling through a little throttling device that you've got at the bottom of that picture. And then because when it goes through that throttling device, it usually comes out colder than the ambient air. So what that means is the ambient air can recharge that cooled liquid just before it goes back into the heat pump again. And then that cycle just continues. So it's a closed loop refrigerative cycle. So same thing as your fridge, your reverse cycle air conditioner. And this also can also be used for heating pools and hot water systems as well. So it's a really basic device. It's been around for a long time. But as we learnt here in Western Australia, with low-cost air conditioning systems just rapidly jumping on the network all at once, we had a major issue with network quality, voltage, things blowing up. So I guess there's a cautionary tale in what happened to us about 10 years ago in terms of broad-scale adoption of this. And there's some interesting work being done about timing of these systems so that they can be done off peak, introducing larger thermal storage solutions so that you can phase change or temporarily move your electrical demand away from your thermal demand. So the picture that you've got there is an air source, so it grabs that extra air from the ambient. There's ground source as well, which will drill a borehole into the ground, and that'll retrieve the heat, the latent heat that's in the ground as well. So there we go, that's a geothermal one. So that's a closed loop system. So you can run polypipe, as you see in those horizontal applications, or vertical closed loop ones just there on the right. So there's a number of different, I guess, ways of bringing that ambient heat into the system, not just air.
And can I just want to mention, because the heat pumps I think was number one on the poll. I guess a lot of engineers are commenting on this poll, and probably them like me love heat pumps because you get it feels like you're cheating the laws of thermodynamics. It's kind of like you get more than 100% efficiency from it because you're moving. You're not creating heat from nothing. You're just moving it from one place to the other. But the way it works, you do end up getting a lot more heat than the electricity that you put into it, right? So
that's right. Yeah. So it's typically termed as the coefficient of performance. So for 1 unit of electricity, you can get 2 to up to 5 or even 10, depending on the differential between what you're trying to heat and your source temperature. So it's that's the great thing about it. It's kind of like a electrical amplifier for heat, in simple terms.
Okay, and then keep going. If you had more you wanted to say about
and I guess just on the hybrid system that we spoke of. So like our technology and some others is that we preheat the air going into the heat pumps, either on the liquid side for typically like a ground source heat pump, or on the air side as we do. And by elevating that ambient temperature allows the coefficient of performance to be much greater than it would be if it was just to scavenge that heat off the ambient. So there's some really interesting, I guess, opportunities in that space in terms of solving some of those problems. So,
okay, so that's the solar assisted one I found.
That's correct. Yep.
Yeah. Okay, and we'll come back to that when we're going to talk about more about solar thermal. So
Mhm.
I just wanted to raise some of the points. Like, I keep a watch on LinkedIn. I'm quite active on LinkedIn, which I know is really, really geeky, but I actually find it a really good way to research new energy topics, because you always get both sides of a debate, sometimes very vigorously and passionately. So
Yep.
one thing people say about heat pumps is that it's great in countries like Australia where we have mild winters, but you can't use it in colder climates. So I did try to dig up some data about where heat pumps are being used, and actually you can see that they're being used a lot more in some really cold countries. So on this chart, we've got how many heat pump units per 100 households, and then on the y-axis, the mean temperature in January. So yeah, Finland, Sweden, Norway up. Well, Norway's 60 heat pumps per 100 households. Yeah, and there's other countries that are obviously cold.
Doesn't get any
And
more
then,
Nordic than that.
yeah, yeah. Well, I mean, obviously Denmark's missing from there, but we've got some nice district heating from. I don't know what they're mostly using in Denmark, but at least some of it's combined heat and power. And then I did troll through all these comments. There's a lot. This one's a particularly I don't know, interesting debate about heat pumps, but apparently in Norway you're actually forbidden from using a few different kinds of heating technology, and you're basically just left with electricity. And so obviously if you're going to use electricity, then you're going to use a heat pump to boost the triple your performance, or do better than if you're just using resistive heating. So
Yeah. Oh,
yeah.
and the conversations we've had in that space, yeah, it's surprising the Nordic countries, as cold as they are, the representation they have in terms of heat pumps. So yeah, they do face a few challenges in terms of frosting, but they've kind of got algorithms around resolving that. But yeah, that we expect to see more and more of those heat pumps sort of rolled out across those marketplaces.
Yeah. Okay. And then also just wanted to read a little comment that I got from the Engineering with Rosie Patreon only Discord. So one of the group members says that he installed a ground source heat pump 12 years ago in New Brunswick, Canada. He loves it. It's great cooling on top of it, minus 10 degrees C, balance point for heating. And he says they lose 0.5 degree in the house for every 1 degree outside. It drops below that, so they need a backup. They use a wood stove for backup on very cold nights, which they source that wood from their local. They've got a forest there on site, so they get the windfall from that. Yeah, and he's using a horizontal trench. And he installed it himself. He said he saved a lot of money that way. So I thought that was interesting. It's the ground source heat pumps. I've never heard of that in Australia. Do you have much experience with those, Glenn?
There's a couple of proponents of them. I guess they seem to again face a little bit of challenge in terms of market. It's foreign, so it's a little bit new to market. I did visit a sports facility in sort of Lyngby, just outside of Copenhagen there, which had exactly this ground source. So under the ovals, they'd laid all that pipe, and essentially they were charging that with the PVT system during the summertime, and heating up the ground and then drawing back down on that horizontal system. So that was quite an impressive little bit of kit. So they were to get very high renewable penetration as a result of that.
Yeah, and do you think, I mean, these diagrams are all showing like a single house connected to a system. Is that the way it's normally done? It looks like a lot of digging to do for, just one house. Is it most normally done house by house or on a district scale?
So I think most of these ones we're seeing is on a house by house. The district type precinct stuff is more, I'd say, more deeper borehole. So the stuff that's the aquifer storage systems in the Netherlands is larger, kind of doublets, larger, deeper. So, but there's the economies of scale doing that. So I think, while you've got a paddock next to your house, that's a very cheap way. You're unlikely to have district heating running past your front gate. So this is a good way to squirrel away the heat to some extent. When you're in higher density buildings, then you need to obviously look at more sustainable solutions, larger solutions, industrial solutions. So, we've seen different applications of precinct thermal storage coupled to heat pumps, as well as the ones I referred to earlier, which are the large Olympic dams in Olympic size, insulated dam pit storage systems in Denmark. So they just use them as a seasonal buffer. So,
Okay.
so I think it's horses for courses,
Yeah, and I have seen some criticism about some systems that are trying to use like the Great Lakes, for example, as their source, and I think there's some environmental concerns maybe related to changing the temperature of those lakes that obviously other things live in.
Well, I think everything comes at a cost, so you've got to be really conscious of where you are drawing and sourcing that energy from. I mean, the same argument could be said for a lot of the power stations are running on the Mississippi, and killing off fish because they get the temperatures too high, or having to back off to prevent that sort of thing. So, everything we do has an impact.
Yeah, but we normally only hear about it when it's an impact associated with clean energy. Everyone, no one seems worried about the impacts of the traditional ones.
That's right. We've got to be squeaky.
Yeah, exactly. You've got to be perfect. If you want to be better, then you have to be perfect. Otherwise you get in trouble. All right, so let's move on then to the next technology, biomass. So as we saw, I'll just bring up that chart again. So of the renewables, we've got the bulk of it is actually biomass. 11.9% of heating is from traditional biomass, and 6.9% from sustainable bioenergy. I don't know if you're the right person to ask this question to, but I've been pondering, why is this distinction made between traditional use of biomass and sustainable? Usually it's called modern bioenergy. I mean, traditional use of biomass is mostly, isn't that just like scavenging dead wood from forests, cow dung, agricultural waste? Why isn't that sustainable? And what's so sustainable about making it into, because a modern bioenergy, it's like turning it into wood pellets or
That's right.
I don't know, biodiesel, or turning it into something, right? Do you have an opinion on why the distinction?
I'm not sure. I do believe that's a classification of the two. So the more your third world countries that are using endemic biomass to just run cookers and the likes. But when they're presented with nothing else, that is an essential fuel type as far as I'm concerned. We've had many people sort of peddling the idea that coal was going to save the third world from poverty and food. I just think that's a farce. But sustainable bioenergy, my understanding is the definition is kind of like it's plantation timbers, it's curated, and then it's processed. So that also may include straw from more modern facilities. I know Denmark had a large subsistence of straw that would go through the system. They also had rubbish, so I don't know whether waste burning is considered in sustainable bioenergy either, but that is a kind of a decent size of some of those district heating systems.
Yeah, I did a video. One of my very first videos was on the district heating in Odense, so on the middle island of Denmark, Fyn.
Yep.
And I didn't know until I got there that they were burning waste. And my tour guide, who's a friend of mine called Bo, he told me that they use different amounts of plastic to control the temperature. And I was so shocked, because I had been carefully sorting my plastic into about 6 different categories, thinking, the Danes are so environmentally conscious that, they recycle everything, but it's just to help them control the temperature of their waste to energy plant. And I have to admit, I stopped being as careful about my plastic sorting after that.
Yeah.
But Denmark doesn't categorize waste to energy as a renewable energy source. I know that Sweden for a while was trying to get away with the idea that they didn't produce waste anymore. But I think, I don't know if you've seen one of my previous guests, Paul Martin, and he's very active on LinkedIn, commenting that he calls waste to energy, instead of putting the waste into landfill, you put it into airfill, because obviously you burn the...
I've got a little story on that one. Is when I was in Copenhagen a couple of years ago, and I had the same smell in the air that brought me back to my childhood, and that was when my mum used to burn the bins on the farm. So we lived in a large broad acre, and every time, sometimes you'd be bringing the sheep in, and you'd smell that same that real nuanced bin smell. So I could smell it, but no one else could. So it was quite ironic. But I think that leads into some of the issues we do find with the conversation around biomass is the particulates and the haze that is caused through biomass. So I think sustainable biomass I think is going to have its place in terms of peaking plants and stuff. But I think we need to look for I guess more baseload heating systems during the course of the year that aren't as creating as much emissions into that airshed.
Yeah, and I think that, my opinion about why they've split the bioenergy into traditional and modern is largely about the health impacts. That's the only real difference that I can see, because burning things inside is terrible for health, as we've learned. I mean, burning them outside is bad for the planet and for people who live in the vicinity, but it's not nearly as bad as burning it inside. Now, I just have to.
Images. I was going to say there's poor images of the Afghanis using plastic, burning it inside a house for house heating. So it's got some tragic consequences, I believe.
Yeah, I just need to go to a conversation in the comments. David Montgomery asked, "What's a paddock?" Which I assumed that was a joke, but sometimes I'm not aware of Australian specific words. Is paddock really is that Australian specific? The Brits know it. Please tell me.
Alternative is a field.
Yeah, we've got Paul Bostwick has chimed in to inform us that it's a grassy field. So anyway, that's new for me. I also learned on a recent video that the word greenie for an environmentalist apparently is an Australian word, and everyone thought it was hilarious. So sometimes I learn a bit about my own language from the international audience. Okay, so shall we move on then? The next technology that I wanted to talk about was clean gases, I'm calling them. So it's not even on the chart here, but it's probably the most talked about, I think. And I'll see, I did find some trials to bring up, some articles to show things like blending hydrogen into existing natural gas pipelines, which is something that I have also made a video on. That one with Paul Martin was on that. And then you can also be making like biomethane, or maybe even some synthetic gases or something. So what do you think about this idea that we're going to continue to use the existing natural gas pipelines and probably also the same gas boilers in people's homes? Is that something that you think?
I've got a pretty decent position on this. I've been very vocal. I'm very supportive of Paul Martin in his claims in terms of the H2 in pipelines. One of my previous roles was looking after energy and gas contracts for a large mining utility, and one of the biggest issues with gas spec was the amount of hydrogen that was in it. So it was always problematic in terms of hydrogen porosity and causing pipelines to potentially crack and fail. So there's a number of big issues that it sounds simple, but there is a lot of technical issues. We've just done a report on the gas pipeline over here in WA to explain, to highlight those issues. So it doesn't bode well for blending. Then you've got the appliances and the likes on the end that need quite some significant changes to their configuration. So it's not like you can have someone on gas and someone on a hydrogen blended system. You've actually got to change the whole thing out before you basically change the gas spec, which is a pretty significant thing. So I'm not a big fan of hydrogen being blended into gas pipelines. I prefer to see that go into higher energy resources like metal production and processing. I think it's more of a precinct fuel, and the purer you keep it, the better, and the high entropy you keep in the system. So that's kind of my view on that. I did trade a bit of hydrogen between a couple of clients on the Kwinana strip. So it is, it's doable at a precinct level, but as soon as you want to store it and buffer it, that's when the issues become more apparent. In terms of biogas, I think this is an opportunity to obviously value add, to put it into energy and electrical infrastructure. So there's obviously lots of biogas facilities around Europe. I really like the idea of I guess, capturing that methane that would have normally gone to atmosphere and putting it to good use. So to me, it's got so many benefits from not just clean energy, but remediation of soils, contamination, and getting that nitrogen kind of concentrated in a place that you can actually reuse. So,
is there enough? Are we ever going to get enough? Because I mean, we use so much gas in those pipelines at the moment. Can we plausibly capture enough methane that would legitimately have otherwise gone to the atmosphere or make it? I just worry about scale with that one.
So for me, the biogas stuff is more about treating the waste and getting the energy close to precincts, so you don't have to use it elsewhere. It will scale up locally, but it'll never replace the big chunk of gas that's coming through from either Russia or our northwest shelf or large gas fields. So we've actually got to look at what's going to fulfill that. That is probably our biggest challenge in the energy system.
Okay. I just got a comment I want to ask from Carl von Holly. Can someone send a link to the article? Do you mean the one that's on the screen now? Because I can just do that right now. You mean that's what you mean? Yeah, so the reason I put that article up is because we've seen over the last couple of years, we saw so many projects announced to blend hydrogen into existing gas pipelines, gas grids, distribution grids, including in Australia, which for me, the trial that's going on, well, there's a few actually. I think there's one in Victoria, one in, or at least near the New South Wales Victoria border, one in South Australia, and you mentioned one in Western Australia. And to me, it's just when it's just such a suitable place for heat pumps and renewable electricity, I think that in Australia, it's completely crazy. Whereas I can understand in, Northern Europe, they have a very different problem and, probably have to expand their search into more technologies. But we are now starting to see some results and some assessments. So this article is about a study from the Fraunhofer Institute. And I mean, it's got the same figures as Paul Martin and I were talking about in the video we did on that. Adding 20% green hydrogen cuts greenhouse gases by just 6 to 7% if all of your hydrogen is, 100% renewable, and would increase end user costs by up to 43%. So I've seen a few people chiming in with these sorts of assessments of studies, but also seeing some people reporting positively on these trials. From a technical feasibility, it is possible. We're seeing people solve problems with boilers and with pipe embrittlement and that sort of thing. So yeah, I don't know if the debate's settled yet, but I think I'm on the same page as you, Glenn. I wish that this idea about using green hydrogen is such a scarce and valuable resource, and I think the last thing we should be doing with it is blending it into
heating our homes with it.
Yeah.
It just seems a total destruction of entropy. We've created this beautiful pure product and we're just going to totally devalue it. Look, I'm big on green hydrogen. We need to start to looking at, but I always advocate that this needs to be a precinct fuel. So you produce it, you use it, you kind of produce high value products out of it, where you can't use induction heating or other forms of low carbon heating solutions or as a reagent. So, yeah.
I get the impression that people are blending hydrogen into the gas grid so that they have something to do with the hydrogen now to kind of kickstart, an industry of green hydrogen production. I still don't agree with it, but that's the only kind of bit of logic that can pull out of all these trials is that they, want to give people a reason to actually start making green hydrogen, because for now there's a lot more talk about green hydrogen than there is actual green hydrogen.
Well, we also hear the case of, we've got to start the industry somehow, so we've got to use blue hydrogen to kick it off. Well, I kind of go, well, I don't think it's going to, anything with a wheel on it is going to struggle with hydrogen in the future, is my personal view. So, we don't need to build that kind of false hope that we're going to get there. Investing, low-cost electrolysers and all those other technologies that enable us to get the green hydrogen. But I really struggle with that philosophy that it's going to be piped into our homes and heat our kettles and ovens.
Yeah, no, I agree. but I do try to keep a little bit of an open mind at least. All right, so let's move on. We've got some good comments in the comments, but they're a lot to do with thermal storage, or thermal storage. So I'm going to save them up for when we talk about that topic. Next, I want to talk about. Oops. Sorry, I need to get back to my outline. Yeah, so next I want to talk about solar thermal, the thermal collection rather than the storage. So I have found this figure that relates to the different kinds. So can you talk us through, how this happens and how it's different to, photovoltaics that probably people more commonly associate with solar energy?
Yeah. So I guess the traditional flat plate, here in WA, we were one of the leaders in solar hot water systems, in particular in Australia. And the flat plate collector is just a glazed box with a series of pipes with water or glycol that goes through it. So it's a very simple, very simple thermal collector, very basic, pretty robust. Does suffer from corrosion, so you kind of get depending on the build, a 15 to 20 year life out of them. But they can be quite efficient depending on your glazing and insulation. So they're a very, effective form of heating. What we have found, especially in the Australian market, is PV has just come in and just commanded the real estate that the solar hot water systems used to sit on. So from a house builder or plumbing, that it's just easy for them to do all the electrical stuff topside, and then they'll just whack a electric boiler in or a electric heat pump in downstream from that. So they've kind of gone out of favor. They're still massive in, how would you say, developing countries, so China and India, big users of these systems, but they're not going out buying PV systems either, so because they're just not as affordable as, I guess, the solar thermal. So we're the dominant flat plate collectors with the dominant sort of technology choice. You probably
so it's just very simple. The sun makes the water hot, and then you take the hot water away and use it. Is that as correct. Simple as it is? Yeah. Okay.
Yeah. So some of them are forced and some of them convective. So they're on an incline, so the hot water rises. So the traditional solar with the tank will actually thermosiphon itself. But sort of larger systems like you would have seen in Denmark, they're connected to the district heating systems, they're typically run by a variable speed pump. So they flow the water through. It still is on similar sort of incline and process, but on a much larger scale. There's up to 100 megawatts on the western fringe of Denmark there in terms of thermal capacity in one of those plants.
Okay.
So we've got evacuated tubes there as the next one. So the advantage of evacuated tubes is they allow the hot water temperature to rise at a higher temperature than you would off your flat plate collectors, because they're typically insulated, so you lose less heat from the actual conducting rod, and some of them also have a mirror underneath them, so they kind of concentrate the heat onto there, so you're getting several sun amplifications on those systems. So they're typically used for either compact spots or areas where you want to get a much higher temperature than a traditional flat plate may get you to.
Okay.
And then you've got PVT or hybrid systems. So this is where our technology fits into. So we have the PV on the top and the thermal element underneath. There's a range of different products out there. They typically use different, so we have different heat exchanger systems, as well as the heat exchange fluid. So our system uses air. There's others that use just water in a serpentine type arrangement. So a bit like you see on the back of a fridge sometimes, those coils. And in there, sometimes people use just water, glycol, or there's some cases of people using refrigerants. So the beauty of that is you get the, the high value product being electricity on the top, and then you got your lower grade product thermal being underneath. So you can get efficiencies up to 50% with these systems as well.
Right. And I do have a question from at the start from Peter F. How do you stop the water in the solar panels boiling? So Sunovate uses air, right?
Yep. So we solve that problem very quickly. Part of the reason why we use air, so we don't have a high, have to worry about those high issues of high temperatures. Traditional flat plate collectors and evacuated tube boilers, they'll typically have a temperature release valve on them. So smaller systems will vent if they get too hot. So our solar hot water system, after a long period of sustained heat, the temperature gets higher and higher, so its actual losses get higher and higher. So it kind of starts to equalize, but there were times where suddenly you got 350 litres of hot water cascading off your roof down a pipe as it trips that thermal overload. There are other mechanisms, other systems use a fan and a coil, and they'll just continually circulate the fluid to then get rid of that additional heat. So, but that's quite a, that's another additional complexity to the system.
Okay. Yeah, I mean, I like the sound of it because it does sound like you getting something for nothing here. Kind of, I don't know, taking advantage of you've already got the PV there, and you're making it more efficient, and then also taking waste and using it. And I always like like bits of engineering where you take some waste and find a way to use it efficiently. So,
Yeah.
do you see?
So what we? Oh, sorry.
Yeah, I was just going to say, where do we see these rolling out? These systems? What are the parts of the world it suits?
Yeah, look, I guess it works everywhere. I guess what we see is like the electricity is typically valued at 3 or 4 times the value of heat. So if you look at those different markets, so that's why it makes sense to put your high value energy producer on top, being your PV panel. And I guess what we're finding is as we move more and more to the electrification of everything, heat pumps and/or electric cars, we're going to put more and more demand on that electrical network. So for us, we see spatial constraints and network constraints as being key enablers to these technologies. We also see, if they're connected to seasonal storage and you can get better seasonal utilization of the heat, the LCOH, or levelized cost of heat, comes down because you're actually using more and more of it. So as we see those sort of 3 things converging, I think you'll see more and more of these systems being applied, basically across the globe. So they're equally as applicable here in Australia as they are in the northern parts of the Nordic regions.
Okay. All right, I'll just get onto a couple of questions and then move on to thermal storage, which is probably the last one we'll have time to cover. So Forza Jersey asks, can fast pyrolysis of non-wood/non-food biomass produce enough biomethane to replace natural gas? It seems scalable at first glance. So do you mean like agricultural waste, or I'm trying to think what? Anyway, can you?
Yeah, look. So I didn't talk on pyrolysis. So that's another form of of a method of using basically carbonous waste. So pyrolysis very quickly is about basically heating a product up under temperature in the absence of oxygen. So you end up with it producing different types of gas, syngas they typically call it, which can be used in an engine or in a heating process, and then you end up with a form of carbon. And there's a range of different technologies that can use different temperatures. I do see pyrolysis as being of organic matter as being a good pathway forward, especially in organic waste streams from agricultural and domestic waste streams. So the great thing about that is we segregate it, and all those nutrients that are in that system as well become recovered, so they don't end up in an incinerator or in an ash pile or a tip somewhere. So we can start to reduce some of our reliance also on those artificial fertilizers and the likes. So I'm a big fan of biochar.
I have a video coming up on carbon capture and utilization, and biochar is one of the more promising areas there. And I know that the research does say that it can scale. There is a huge amount of agricultural waste, and if we used a significant chunk of that, then we could really make a dent in some of our other problems. Okay, a couple more questions quickly from Paul Bostwick. Is there an electrolysing approach that also keeps the oxygen handy so when recombination is more efficient than naturally aspirating the systems? And my understanding on that is that people only do it when they have a local use for the oxygen, and that's usually that's rare. So in general, the oxygen is harder to compress and transport and store than it is to just get it from get it where you need it.
Well, the trouble with that also, Rosie, if they try and introduce it at the same ratio inside an engine or a gas turbine, you don't end up with the blades don't last very long. So you kind of you've got to get the right ratios of oxygen and inert gas there to preserve,
okay.
So you don't flame out.
Okay, now I'm just going to show this question. I can't answer it because it would take several hours to say everything I have to say about that. But from Carbon Holly, many people not so deep in topic are convinced hydrogen will be useful for heating, storage, etc. How do you explain the big divide between public opinion and scientific perspective? And I'll let you say your opinion on that in a second, Glenn. But for me, I think the idea is it just sounds so good. Hydrogen is one of those topics that if you think about it for 30 seconds, it sounds like it's going to solve all your problems. But if you think about it for 5 minutes or longer, then you just start to uncover problem after problem. And I think that's the issue is that, difference between 30-second analysis and 5-minute analysis is a fair amount of, scientific training, engineering training that most people, politicians, climate change activists don't have. That's my understanding. What do you think, Glenn?
Look, I mean, it definitely can do heating. There's no doubt about it. I guess my argument is, we've got a huge energy challenge on our hands, and we need to, I guess, rank what we want to use the different materials for and those different processes for. So, for me, heating hot water with hydrogen, it may have some application in unique places, but it's not going to be the broad solution for our cities and our larger precincts. So I would rather see that hydrogen being directed to displacing all that grey hydrogen that's currently in our system, which accounts for close to 10% of our greenhouse gas emissions. So that's where I want to see large scale effort in hydrogen, is getting into that sector, decarbonising its own sector, and then look at new innovation around steel and minerals processing.
Yeah, I think that's a really good way to summarize it. Hydrogen at the moment is a decarbonisation problem, not a solution yet. Okay, so we'll just keep on moving because we're running out of time. I just want to move on to thermal energy storage. I've brought up very fine resource here, Wikipedia, my first go-to usually. Like I said, I think I said at the start that I didn't even know this was possible. It sounds so implausible that you can make something hot and then in the summertime and it will still be hot when you want to use it in the wintertime. So can you explain to me, Glenn, why that is incorrect, my assumption?
Yeah, so I guess that was a great thing about a couple of years ago driving through Denmark and looking at those places is they do have like that tank on the right there. That'll be probably more of a like a intra-week buffer. So they can buffer against larger wind events or solar deflunkes, I think you call them.
Dunkelflauder.
Dunkelflauder. That's bad with my interpretation. So this is good to keep the heat close by, but then they have those larger storage tanks. Like I say, there's several Olympic swimming pools deep. So I guess just because the pure volume of them, it's a bit like the analogy is, I guess you take a hot water bottle to bed with a little cozy on it, and it's still quite warm in the morning. So it's the same with that. Just the scale of it heats up the earth around it. So it's kind of, even though the top's only insulated, the edges kind of use the earth as, again, some additional thermal mass in that. So they just draw off that over the course of the winter and supplement with additional solar that's received during the wintertime period. And hopefully they've sized it sufficiently enough that they don't have to rely too much on their auxiliary heating solution. So they still have a oil burner or typically a like a biomass boiler adjacent to these as kind of the emergency storage.
Yeah. Okay. So I'll just translate it. This is the world's largest pond heat storage in Voyens, which I think is in Jutland, in Denmark. So it's water storage, and yeah, I think that they're heating it with solar in the summer mostly.
They are.
Yeah, it's crazy. Look how big it is, and just water. I mean, if I heat up a bath and then try and come back and use it the next day, it's not warm. So how are they keeping it insulated well enough?
Well, it's a bit like when you first charge a gas pipeline, you have that energy that you need to kind of create the line pack. Well, when they start introducing the heat in here for the first year or so, you're kind of creating that heat insulation with the earth. So the earth will build up and take some of that heat out of there, but it kind of then acts as a long-term insulator. And on the top, you'll probably find that they have about a foot or so of polystyrene, covered plastic. So it's got a nice tea cozy over the top of it to keep all that heat in. So it's not exposed to the environment really, and just the sheer volume of it. It's, what are you looking there? 200,000 cubic meters. It's just massive. So when you look at that in terms of a pit storage, it doesn't have a huge amount of area relative to the volume because of just the scale of it.
Yeah. Okay. And so, what are some of the other methods that are being used besides just water, and what else? Yeah, and where around the world is this being used?
Yeah. So this is mainly Denmark, but I'm seeing other people taking interest in it. As I said, in Netherlands, they're starting to look more and more at the implementation of aquifer storage. So it's obviously suits their landmass better to look at aquifer storage. So that's where they bury the heat and cooling underground, so they can buffer hot and cold. Places like the UK are looking at mine sites, old abandoned mine sites, to use as a thermal reservoir. So these are all great because you then don't have to rely on those peaky gas periods where you've got that high demand. So the more and more you get that thermal storage out there, the flatter the curve will be in terms of demand from those external sources. You do see some like street level storage systems, so smaller hubs, and we're also starting to see at the smaller scale some where you want really compact heating systems. They're starting to introduce things like phase change materials or chemistry salts and things like that. So not only do you have just the sort of temperature rise of the water, but then you've got the phase change of the salts. So a bit like the energy it takes to boil water, it's just that big step change in latent heat. So that allows it to be a lot more compact. Right.
I found also this this project in Alberta, Canada, which is what is it, 52 yes. single family homes. So it's a district heating, small district heating with some short-term thermal storage, and then borehole seasonal storage. And they give, it's a little bit old now, I think this data is from 2014 or something, but they show the annual system performance. So I guess that this is how they started out, and then as the system charged up, that it got more efficient. Is that your interpretation of those graphs? Does that sound about right? Obviously, it's slides from a presentation, and I didn't get to hear the words that went with them. But I know they got over 90%. Right, yeah, they get over 90% on average solar heating. And I mean, Alberta is not a mild climate in the winter time. So yeah, it was pretty.
Yeah, that's what I reckon there. You've those first couple of years is probably what's taken to get into equilibrium in terms of the, just getting that those ground loops sort of at a steady state.
Yeah, and then they show how they expect it to perform over time. So yeah, obviously you got this starting up period, and then the red line's an average year, and then the blue line's some real data from 1950s to 2000. So yeah, I think that's really interesting. Why do you think we don't see that more? It's not like I hear people talking much more about hydrogen in gas pipelines than I do about storing, renewables as heat seasonally.
Well, I think it's because heat pumps have really just started to come on the scene, particularly here in Australia, but in more general, like the market's growing, and then the air source solution has got some limitations, in terms of, it can't access the, it's got to run with the ambient conditions as they present themselves, whereas ground source, you've got that thermal buffer there, which you can charge over summer like they've done here. So I think it's a lot more capital intense. So that's also another barrier. Like, people want cheap and cheerful. These systems should last, 30 plus years. So, but the trouble is, people kind of, I guess, in that investment mindset, you have to have the confidence to go and do that. And, I guess I recall when solar was put on Perth houses here, it was a greeny tree hugger thing. And then it kind of got to that point where it didn't, it suddenly became the Joneses, as we say. And, when it became household conversation of why we don't have it, then, we just got massive deployment of it. So no one questions that now. I think this will be the same. Like, it's an emerging tech. There's a couple of different pieces to it. But I think once we've got more demonstrators, this sort of technology should become mandatory to some extent in terms of new builds and new precinct developments.
Yeah, obviously it's hard to set up district heating in an existing neighbourhood, but if you're starting from scratch, it seems like, new developments. It's really nice. I mean, I loved having district heating. It was nice and it was cheap, and I thought it worked really well. It's obviously, Denmark's quite dense population. Even in the small villages, houses are close together. So you couldn't put it in the suburbs in Canberra, for example, I don't think. But
that's where borehole would kind of certainly come in, individually or community street-based ones. But the other thing that we didn't touch on is just the thermal fabric of the house. So if it's well insulated and it's a brick type construction, that actually helps you ride through 3 or 4 days of low solar input to not need any other form of heating or storage.
Yeah, and I don't think we've got time to talk a lot about energy efficiency, but it's what my number one pick out of all the the options that I put my vote where I live is for better energy efficiency, and mostly double glazing and insulation and sealing up drafts. I rent currently, and we're looking to buy a property, and no one has renovated with energy efficiency in mind. It's crazy. We've got I don't know what our star system is in Australia. It goes from 0 to, 7 or something. And everything in Canberra is 0. You're lucky if you find something that's 1.5 stars. And it gets, it gets pretty cold. And people say, oh, you never put double glazing in because the payback period is so long. It's, more than 10 years. But I want to feel comfortable in my house, actually. It's not just about the payback period. So, when I do buy a house, I'll be doing a big energy efficiency renovation when I can afford it. So, yeah.
I totally agree.
Yeah. And I'll get a Sunovate system on the roof.
We'll sort that
out. Okay, so we are running out of time. We'll have run out of time. So I just wanted to find a few more comments. Maybe you know the answer to this one. Sorry if I put you on the spot for something technical question you don't know. Paul Bostic asks, what temperatures are the Danes running these storage areas at?
I think about 90 degrees. 95 degrees.
Yes, you're correct. I can verify in the article. Yeah, 80 to 90 degrees at the top.
Oh, there you go, 80 to 90 degrees.
At the bottom. Yep. Yeah. Oh, and the thing that I thought was really interesting was over the year they lose 7 to 8% of the heat production in the entire system. I mean, that's fantastic. And if you compare that to I don't want to do this whole live stream dumping on hydrogen, but you compare it to the efficiency of making hydrogen with electricity and then using it to make heat. I mean, definitely below 50%.
Yeah, so we can handle 7 to 8%.
Yeah. Okay. Just another comment from Supers05. For the record, heat pumps are a decades-old solution, water source and heat source. And they have been around forever, but now it's all of a sudden people are prepared to accept that this is a technology that works. Has there been big improvements lately, or is everyone just finally realizing how cool heat pumps are?
Oh, look, there has been certainly material improvements on the controls with variable speed drives and refrigerant types. Improving hydraulic side of it, so getting much greater COPs. So there is definitely an improvement on that. But I just think part of it also is just a shift. Like it's seen as a clean energy solution. You don't need to bring gas into your house anymore, so you can just have one energy carrier into the house. You can run it off the solar. So I think that's kind of what's really started to drive it, and the policy has supported that. So but gas boilers have historically been quite a lot cheaper than heat pumps. So people now, I think, starting to consider operating costs and things like that as well. So
Okay, I'll just do one final comment, which is a bit of a tangent. John Way says there's an airport somewhere with a collector pipe under a runway, and they store the heat in an aquifer and keep the runway bare and dry all winter in snow, plus use excess heat for heating buildings all winter. Anybody else
Yep.
heard of that and know where it is? That sounds awesome. I know they heat the footpaths, the sidewalks in Sweden, northern Sweden, where I was working a lot on some wind farms up there. That it was so cool that their footpaths are free of snow in the winter because they're heating them. I never thought of doing it to an airport. I guess it's important to keep that free of ice as well.
Yeah, I haven't heard the airports, but I have heard of the road pavers and footpaths.
Yeah.
I think in Rotterdam, I think they've got some underfloor paving there.
Yeah. Okay. Rotterdam has a lot of interesting projects. They've also got one of those blending hydrogen into gas networks projects there as well.
They got everything.
Yeah. I think, the Netherlands is one of those countries with a slightly challenging energy transition because they've got so many people and not that much space and a slightly challenging climate. So, but the Dutch are known for coming up with crazy technological solutions to problems. How much land have they reclaimed from the ocean? The country would be a lot smaller without engineering.
Well, they've actually driven up, I guess, a fairly aggressive policy in degassing as well. So they've actually, pulling out the gas pipelines in streets. So they're actually fully converting them over. So, they are. There's an interesting sort of precinct being set there.
Maybe I need to do a road trip to Rotterdam someday. haven't been doing so much traveling recently, obviously. Okay, so we'll leave it there for today. I've learnt a lot from this. I think I mentioned at the start that I was so naive about heating growing up in Australia, and but if you look at the numbers, it's such a huge part of the energy transition that we should definitely all be talking about it more. I think that there's some really great technologies available. It's just a matter of rolling them out. Is that how you feel, Glenn?
Oh, absolutely. Like, I think, there will be some improvements along the way, but, we have a portfolio, of different technologies in the solar thermal, the bio, to really give this a good, I guess, good knock on in terms of, solving this crisis in terms of renewable heat. I think once we get targets and mandatory targets, everything comes down with scale, like we've seen with the heat pumps. We'll see the same with all these other technologies. Once they're adopted, the cost curves will come down, then the adoption, and then it'll just self-fulfill from there.
Okay, and are you seeing the right kinds of political attention on this? Are people starting to think about making some good policy to drive good behaviours?
Not here in Australia, unfortunately. That's why we look overseas. But we are seeing, I guess, Germany is probably one of the shining lights on the hill for us. They've actually going to start to set in mandatory, renewable energy targets of, I think, about 1.5% to 2% growth per year. So that'll just create a beautiful market sort of to put these products into. So for us,
heating, the targets for heating specifically,
renewable heat targets. Yes, very specific.
Okay.
Yeah, so they've realised that it's been lagging, so they actually have to take a sectoral response to the problem.
Yeah. Okay. So anyway, wow, fascinating topic, and I'm looking forward to see really fast change over the next few years. Surely we're due for an inflection point. So just to wrap up, big thanks again to the sponsor, WeatherGuard Lightning Tech. They also have a great tech newsletter and a podcast that I co-host with Alan and Dan each week, and the links for both the newsletter and the podcast are in the description. So we talk about clean energy tech news. in the latest podcast episode, we talked about offshore wind and some related issues like how it can work in hurricane-prone areas like Louisiana, and the need for more specialized ships to ramp up offshore installation, and also the idea of putting carbon capture directly onto offshore wind turbines from direct air capture. And I think, Glenn, you were in an episode with Uptime as well, weren't you?
That's right. Yeah, yep. They're good guys, aren't they?
Yeah, we have fun. Yeah, so check out that and Glenn's episode as well. I'll put the link in the description a bit later for his episode. You can watch it on YouTube or in whatever podcast app you use. And then I also need to thank again the Engineering with Rosie Patreon team for their support. Actually, on this topic, some of the Patreon team definitely way more knowledgeable about it than me. So I learned a lot from the Discord discussion. So if you're keen also to join in the energy nerdiness on the Patreon only Discord server, then you can find the link to sign up in the description. Yeah, and I'll just talk a bit about what videos are coming out. I have definitely had a bit of a slow start to 2022. I've been sick and away, and yeah, everything got messed up. But there are a few coming out. Should be roughly fortnightly from next week. I've got small modular nuclear reactors, which I know there is a lot of interest about, carbon capture and utilization, zero emission steel, and still there's an update on my levelized cost of energy video to add nuclear and geothermal to that. Also lots more in the pipeline. So yeah, I think it's going to be an exciting year for Engineering with Rosie this year. So thanks, Glenn, for taking the time to chat with us today and sharing your very broad and also deep knowledge on this topic.
I appreciate it.
Yeah, it's been really good. A couple of Australians telling the Northern Hemisphere all about renewable heat. Well,
I'm
not
sure
so I wasn't so much telling, but yeah, me asking all the stupid questions. Yeah, and thanks everyone for watching. Of course, there's no point to these live streams without a good audience and good questions. And I'll see you in a couple of weeks, probably the next live stream, which is probably going to be on airborne wind finally, which is one of probably my most frequently requested topics. So looking forward to finally covering that. Yeah, and yeah, thanks again, everyone. See you next time.